Okay, this is 8.4 proportionality theorems. What I'm going to do, you should have had this written down from your book. I'm going to kind of translate this into sometimes just looking at the geometry over and over and over again. Gets to where you're just staring at it and just a bunch of random letters. I'm going to translate this kind of into maybe algebra, more of an algebra looking problem, where instead of having line segments, I'm just going to assign variables. So, and correct me if I'm wrong, that this would be B over A equals Y over X. Is that what it says? Is that what the theorem says? Yeah. Okay. What if I get it all mixed up in my head and I write it like this instead? Because this is what I want to do. When I look at the shape, I want to do it like this. What happens if I do it like this? Will I get the right answer? What I want you to understand about proportions. Did anybody ever play the game Chutes and Ladders when they were little kids? So you hit a ladder, you go up, you hit a chute or a slide, you go down, right? That's how cross multiplication works. It's like chutes and ladders. I'm allowed to switch the place of A and Y and still get the same answer, right? Because my first step of cross multiplication is what? A times Y. Yes? And so does it matter if the Y is here or here when the first step is just to multiply the two? Could I also switch B and X if I wanted to? So this is what the theorem says literally. One of the other theorems we've had early in the book actually tells you to do this. But what I want you to know is whatever you see, it works. This one makes more sense to me because it's like, basically A over X, B over Y. What the actual theorem says is, A over B or B over A equals Y over X. You can do either way. Okay, and that goes with this next theorem. This next theorem is basically the same as this theorem, except for it's not a triangle. Although if I kept these lines going, would it make a triangle? So it's kind of the same. That's where it comes from. If we were doing a proof, we'd use a triangle to prove it. And so what it says is, let me see if it's right. So it says basically this would be A, and this would be B, and this would be X, and this would be Y. So is it exactly the same? Is it exactly the same? BA over YX. Could I also, because I don't like it, and I personally just don't like it, could I also instead do the B over Y equals A over X? Would that work also? Okay, so those are two ways to look at basically, yes, they're different theorems, but no, they're not. They're the same. They just use this theorem to prove that it works for parallel lines with two transversals. Okay, moving on to the third one. I don't know if I'm going to be able to do something like this with it. But, I'm trying to break it down so you can have some choices. So this would be A, and then this would be B, and this would be, well, let's not do it like that. Let's do it this way, and then I'll set it up. A, B, X, Y, just like I've been setting them up. So basically this would be B over Y equals A over X, right? Is that what it says? You can't see it, but you can imagine what it would be like if you did. Is that what it says? Did I translate it correctly? Okay, and again, I don't really like this. I don't like how they write the theorem. It's a good theorem. I usually do this. I usually switch these two again and do B over A equals Y over X. Could I do this upside down instead? Could I do it A over B equals x over y. I could do that as well, even though that keeps looking like a 9. Okay, so I could do a over b, x over y, or I could do it how the theorem says it. Either way, and again, I'm just playing chutes and ladders. I'm allowed to switch those two on a diagonal line. Could I switch the two on a y and x like this? No, that's not how cross multiplication works. That's not how chutes and ladders works. You have to do it diagonally. Although, probably in the chutes and ladders game, there are some ladders that don't go diagonal, but I think the one that's really fun is diagonal. Okay, I'll look it up. Okay, so that's what you can do. You can set it up in a bunch of different ways. I honestly don't think I need to help you on this. I'm not going to put it on the recording. I don't really think I need to help you with this. I think you can set this stuff up. You know, just looking at this shape, which theorem is this? Is that just the first one? Okay. Looks like we're missing this one. So you're going to set up a proportion based on that theorem and solve. Okay. Same with this one. Let's move on to this one down here. This is using the wow. This is using the converse, which I didn't go over, but that's just this theorem backwards, right? So to prove that these things are parallel, you just have to prove that, 12 over 7.5 equals 8 over 5. Or 12 over 8 equals 7.5 over 5. Either way you want to set it up. Okay, let's see if I need to do this next section at all. We're not doing I might get, depending on the year that you're listening to this, I might I'm gonna have you do a couple of these just to test out how that works on the computer. Okay. On this one, we're just setting up the proportion with the theorem. It's pretty straightforward. You just have to figure out which line segment goes here. Okay. I really don't think anything's... Now, this one might be kind of more difficult. Let me scan in here. You see how 21... You see how 21 has... that's very small. I don't need the 29, do I? The theorem doesn't have a big long line. It has short lines, right? Is it easy to figure out what it is from here to here? Yes. I mean, you subtract 29 minus 11. So don't let that fool you. I think that's it. I think we're good. I'm going to plug it into the computer, and at least this year anyways, and then we will move on.